What up, everybody? Back again here with our area unit, and today we are talking about finding the possible dimensions of a rectangle. So let's uncover our objective today. Our objective today, I will be able to find the different possible dimensions of a rectangle when given the area. And here we have the all-important area formula. Area equals length times width. We discovered this formula together in previous videos. If you have not seen those, I would encourage you to go back and watch those. And now we're going to use this formula today in a different way. We're going to take our skills that we've learned in previous lessons and apply them in a new way today. But before we do that, we need to rewind back to arrays. So we've talked a lot about arrays and how when we find the area, really that is an array because we're trying to cover a shape with unit squares, and how when we do rectangles, that makes an array. And so let's go back to a skill we talked about when we learned about arrays, and it says make two arrays that have a product of 8. And so we learned that you can take our product, right, and you might have to try different ways, but you can make different arrays that have the same product. So if I do it this way, the easiest one for me that I always think about would be 1, 2, 3, 4, 5, 6. I need 2 more. If I have one row of 8, that is an array, right? So I have 1, 2, 3, 4, 5, 6, 7, 8 columns, and they each have 1, which means my factors can be 8 groups of 1. And then you can actually turn this, and it's the same array. We can just flip it, right? And I don't really have a lot of room for that. I can put it right here. And now we have one group of 8, right? And both of these give us the product of 8. So really that's the same array, and we talked about that you can flip the array and it doesn't change the product. But what's another array that we could use to make a product of 8? So I know 8 is an even number. That's my thinking here. So if I make groups of 2, I have made a different array that still gives me the same product. Now I have 4 groups of 2. And again, I could rotate this, and I could write it as 2 groups of 4, and both of these are still going to give me the same product. So you can see here, right, no matter the array, you can flip it the other way and switch the factors. That's called the commutative property of multiplication. But our key thought to take away from this is that there is normally more than one way to draw an array to get a specific product. That's a lot of words for a key thought. What we're trying to say is unless the product is 1, you can flip the array to switch the factors, and if it's a composite number, you can make 2 completely different arrays to get the same product. Those are properties of multiplication, right? And so if we take this knowledge and we apply our array knowledge to area like we have before, right? That's how we came up with the formula for area. We can do the same thing, but with unit squares. So this says, what are the possible dimensions of a rectangle that have an area of 10 square inches? So you can make several different types of rectangles that have the same area. So here we have a rectangle that has an area of 10, and our dimensions were 5 units long and 2 units wide. Just like we did before with 8, but we did it with an array, now we're covering it with unit squares. We're treating our unit squares like we're making an array. Because in fact, our area formula, area equals length times width, comes from the fact that when you do area, you are making an array. So what's another way? Now I know I could flip this and do a length of 2 and a width of 5, okay? But what's a completely different array that I could make? And if I think about the factors of 10, I know that 10 and 1 are factors, so I can use the dimensions of 1 unit for my width and 10 units for my length. And again, I could flip this and make my width 10 units and my length 1 unit. It doesn't matter because of our commutative property of multiplication. But these are the different possible dimensions that I could have for a rectangle and make an area of 10. Here I just have a long skinny rectangle, but I've covered it with 10 square units. Here I have one that's 5 units long and 2 units wide, but again my area is still 10 square units. So the key thing to take away from this is that you can have rectangles with different lengths and widths that have the same area. These are 2 completely different rectangles, but the area is still 10. Now the good news about these questions that you might see if you were in a math class is most of them are multiple choice. So here's an example of how they might ask you this skill. Typically, they're not going to make you come up with a random rectangle that has an area of 18. They're going to give you multiple choice answers. So let's take a look at this word problem. It says Elijah is trying to paint the wall in his room. His wall is 18 square feet. Which of these shows his walls correctly? So I can't really write a statement here because I'm not going to be filling in a number, but I can always identify as part of my sides check word problem strategy. And I know because it said square feet, this is talking about the area. I'm looking for which of the answer choices is going to have an area of 18 square feet. So there are several different ways to go about this, but if your question is a multiple choice question, make this easy on yourself. Instead of drawing out all the different possible answer choices yourself, like we just did in the conceptual part of this lesson, you can take your area knowledge and look for which rectangle is covered with 18 square units, right? And so for this one, it would be feet. So each of these is going to be a square foot. If I look right here, I see I have a width of 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and a length of 10 feet. And so if I do my area formula, I could do area equals 10 groups of 2, and that is going to give me an area of 20 square feet. I abbreviated square with SQ, so I know A cannot be the answer. If you don't want to use your formula, you could just count 2, right? So for this, I'm just going to count. I have 2, 4, 6, 8, 10, 12. My area for B is going to be 12 square feet. So that one can't be the answer. If I look down here at C and D, okay, I see 2 that are pretty similar, but they're not the exact same size, so I want to count them. So here, I don't want to skip count, I just want to use my formula here. Okay, so I know I have a length of 4 feet right here, and a width of 1, 2, 3, 4, 5, 6 feet. So when I do my area formula for C, I have length times width, which is going to be 6 times 4, and so my area for C is going to be 24 square feet. Okay, and I know that I'm looking for 18, so that one can't be the answer. So my answer has to be D, but we always want to double check because maybe we made a mistake. So here I have a length of 3, and then I have a width of 1, 2, 3, 4, 5, 6 feet. And again, it doesn't matter which one your length and width is because commutative property of multiplication. If you flip this, you could say the length was 6 and the width was 3 and it wouldn't matter. So my area formula to figure out how many square units cover that is going to be 6 times 3, which gives me an answer of 18 square feet. So my answer that matches up with the information they gave me is D. Now, if you noticed, this is an Instructabeats test taking tip. Sometimes you have to work backwards. They gave me the answer of 18, and then all I had to do was solve each answer choice. But I showed work for each one, okay? And that's sometimes how they're going to ask you this type of question. They're going to give you the area and then have you find the rectangle that has the dimensions that would give it an area of 18 for this question. So let's take a look at a you-try problem. So for this one, it says, which of these rectangles could have an area of 24 square units? And here's the key right here before you pause it and try it. There can be more than one correct answer for this one. So if you are ready, go ahead and push pause, try it out, and then push play to check your mastery. If you're not ready yet, that's okay. You can just do it with me as another we do problem. Hopefully you just paused it. And I know, again, there's not really a statement to write, but I'm looking for the one that has an area of 24 square units. And I know that this was area because my units were squared, right? And that's what area is. You're covering shapes with square units or units squared. So all I need to do now is find the area of each of these and see which one has the area 24. You can either count the square units because these are covered, or you could use your area formula. So here I have 2 units as my width. My length is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 units. My area is 12 groups of 2 or 2 groups of 12. It doesn't matter. And my answer would be 24 square units. So I know that A is an answer choice. But again, it said there could be more than one correct answer. For B, I have a length of 2 and a width of 1, 2, 3, 4, 5, 6. So if I had 2 groups of 6, that would give me an area of 12 square units. Again, if you noticed, for the first one, I used my area formula. And then for the second one, I just skip counted because I have the squares here and I can just count them. So B cannot be a correct answer. C, I have a length of 4 units and I have a width of 1, 2, 3, 4, 5, 6. And again, if I use my area formula here, that would be 6 groups of 4 and my area would be 24 square units. Okay, so I know that C is also a possible answer choice. Let's just check D down here. I have a width of 1. Okay, so I just have one row. But I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 24 units as my length. And again, if I just did 24 times 1, I know that there are 24 square units that cover this rectangle. So again, you can have an area and have a rectangle that looks different and has different dimensions. 12 times 2 make 24. 24 times 1 makes 24, and 6 times 4 make 24. Different factors, like you learned about in multiplication, can be used to make the same product. Let's take a look at the challenge zone. Here's our challenge zone question. It says draw all the possible rectangles that have an area of 12 square units. If you don't want to try this out because you are not ready for it, that's totally okay. This is a challenge zone. You can skip ahead. Just like and subscribe before you turn off the video. If you want to try the challenge zone question, go ahead and pause the video, try it out, and then I'll solve it, and we'll see if we have the same answer. So here I want to draw all the possible rectangles that have an area of 12. So I'm actually going to make a chart here. Okay, and the reason I'm making a chart is because I don't have multiple choice answers, okay? And I know that I want the area, there we go, to be 12 square units. I'm going to put square units here. Okay, and I know I'm looking for what length and width make 12. So I'm going to think about area just as a normal multiplication equation, and I want to know what factors can I use to make 12. All right. Well, the easiest one that I always know is 1 and 12. Okay, so if my length is 1 and my width is 12, that would be a rectangle with an area of 12 square units. So let me go ahead and draw that. I also know that 12 is an even number, so I could do 2 and 6 equal 12, right? So I could have the length of 2 and the width of 6. Again, I could also flip these, but I was looking for not the same rectangle turned, completely different sized rectangles, right? Which is why I didn't do 12 and 1. I just went to 2 and 6. So here, okay, I'm going to have a little bit wider rectangle and a little bit shorter rectangle, okay? Now, let's see if I can do 3, okay, because I have 1 and 2. So if I skip count by 3, 3, 6, 9, 12. So I could do 3 times 4 would give me another rectangle. So I have 3 and 4. Oh, sorry. My area is going to be the same here, 12 square units. And that would obviously be a little bit wider rectangle and again a little bit shorter one. So now I have 4 and 3. And those are all the possible rectangles that you could have with an area of 12. So I drew them out. I also made this chart. This chart's going to come in handy when you start doing more high-level math. But I was just kind of thinking what factors make 12, and then I just went ahead and made those dimensions of my rectangle because again, arrays and area are the same thing. So thank you so much for joining us today. We really appreciate it. We hope that you will like and subscribe. Please continue to check out our area playlist. You can check out our awesome area and perimeter song. We'd love to have you subscribe and join our Instructabeats family. We appreciate you. Thank you. Instructabeats out.